Hello, sixth graders. Welcome to sixth grade math, the coordinate plane lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can use the origin and quadrants to locate points on the coordinate plane by completing practice problems with 100% accuracy in multiple attempts. Here is our standard that we're going to be addressing today. Plot and identify rational points on a coordinate plane and on a horizontal or vertical number line. And a key idea for us. Previously, we plotted points with positive coordinates. Now we are moving on and we will plot points with positive and negative coordinates. So the coordinate plane is formed by the intersection of a horizontal number line and a vertical number line. The number lines intersect at the origin and separate the coordinate plane into 4 regions called quadrants. This is a little bit important here. When you are describing where a point is, you'll need to know which quadrant it is in. So we start with quadrant 1 being where all the positive numbers are, positives and positives. Quadrant 2 is where we have a negative x coordinate and a positive y. Coordinate 3 is where everything is negative. And coordinate 4 is where our x is positive, and our y is negative. So need to keep those in mind and be sure you get that information into your notes. An ordered pair is used to locate a point in a coordinate plane. An ordered pair has the x coordinate first and the y-coordinate second. So looking at our first example, we are identifying ordered pairs. So it asks us which ordered pair corresponds to point T. So we're going to talk about the steps here. So it says point T is 3 units to the right of the origin and 3 units down. So we needed to locate point T and figure that out, didn't we? So point T, we went 3 to the right and 3 down. So the x coordinate is positive 3 and the y coordinate is negative 3. So that means the ordered pair is 3, negative 3. And you need to be sure you always put parentheses around your ordered pairs, and that corresponds to point T, so the correct answer is C. Example 2A, we're going to be plotting ordered pairs. So we're asked to plot point. For A, we're asked to plot -2, 3, and we'll worry about B in a minute, in a coordinate plane, and describe the location of each point. So -2, remember that the -2 in that is the x coordinate. So that's the one that goes horizontally. So you can always look, they're usually labeled. So x goes horizontally and y goes vertically. So the -2, we go across and we go to the left because it's negative, and then we go up 3 for the y, and that's where it lands. So our steps here are start at the origin and move 2 units left, so that would be about a step 1, and then move 3 units up, that would be about a step 2, plot the point, and then the point is in quadrant 2. So remember, this is quadrant 1, This is quadrant 2, this is quadrant 3, and this is quadrant 4. And we like to do those with Roman numeral, but sometimes we use just regular numbers as well. Okay, we are on example 2b, and so now we are plotting 0, negative 3.5. So our x-coordinate is 0, so that means we don't go anywhere on the x-axis, but our y-coordinate is negative 3.5, so that means we need to go down 3.5 units. So we zip down here 3.5 units, and we are right on that y-axis. So instead of having to choose a quadrant, this time we just say that the point is on the y-axis. Example 3, we're finding distances in the coordinate plane. An archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? So it says the length of the chamber is the distance between -4, 5, and 2, 5. So that's these 2 points right there. And the width of the chamber is the distance between 2, 5 and 2, 1. So that's this point again, and this point. So we could just count them on our graph, and that would work, and that's fine, but you have to count very carefully, or you can use absolute values to find the distances between the points. So here, where we're looking for the width, we want to add the absolute values. So we have a distance of 4 here, and we have a distance of 2 here, so that makes this width a distance of 6. And then looking vertically, we can see that our 2 distances overlap. So we have the absolute value of 5, which goes from 0 to 5, and we have the absolute value of 1, which goes from 0 to 1. So that's why we are subtracting the absolute values here instead of adding them. So the absolute value of 5 is 5, and the absolute value of 1 is 1, and so 5 minus 1 equals 4. So the secret chamber is 6 meters long and 4 meters wide. And example 4, let's read the little paragraph before that. It says you can use line graphs to display data that is collected over a period of time. Graphing and connecting the ordered pairs can show patterns or trends in the data. This type of line graph is also called a time series graph. So here's our situation. A blizzard hits a town at midnight. The table shows the hourly temperatures from midnight to 8 a.m. So you can see that after midnight, which is going to be on the x-axis, 0 hours after midnight, our temperature was 7 degrees Fahrenheit. 1 hour after midnight, it was 5 degrees, and so on. And so we are displaying that data in a line graph. So we wrote the ordered pairs here. You can see how the hours are the x and the temperature is the y. And then you plot and label each of your points on the graph. And then you connect the ordered pairs with line segments. Now for part B of that same example, we need to make 3 observations from the graph. And the book is awfully nice and helps us out. It gives us 3 possible observations. And the first one is the hourly temperatures decrease from midnight to 6 a.m. So I'll show you where that is on the graph. So if you look at the hours after midnight, so if we're at 0 hours after midnight, or right here, and then you can see that they go down all the way until 6 a.m. So that's a good observation. And then the hourly temperatures increase from 6 a.m. to 8 a.m., which is correct. They go up like that. And then the greatest decrease in hourly temperatures from 1 hour to the next is 3 degrees Fahrenheit. This happens twice, from 2 a.m. to 3 a.m. and from 4 a.m. to 5 a.m. So if we look carefully, we can see that the graph is steepest here and here. So they're tied for who gets coldest the fastest there. So I bet if you look at this, you could find some other observations about those hourly temperatures. Here's what you need to do next to finish this lesson. You need to be sure your notes are complete in your ISN, complete your Google form questions, review your lesson if you need to, and complete your Big Ideas math assignment in your Math Spiral notebook. Be sure you submit that when it is 100% correct, not before, and track your progress on your playlist.